Hello, in this lecture I will try to answer the question, is the universe infinite? The universe, first of all I will explain what is the universe. The universe is all of space and time and their contents, including planets, stars, galaxies and all other forms of matter and energy. The Big Bang theory is prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. So the Big Bang theory is the prevailing cosmological description of the development of the universe. According to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the universe, of the entire universe, is unknown, it is possible to measure the size of the observable universe, which is approximately 93 billion light years in diameter at the present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang, so any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but is impossible to say for sure that is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privileged or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on all large scale the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could be positive curvature, like the sphere here. positive curvature which is like a two-dimensional curvature of the surface of a sphere. Yes. That is to say, the universe closes inward. Yes. And it is finite like the sphere, like the sphere. The second possibility is the zero curvature, which is like a flat plane, like here, flat plane. Then the universe is not closed but infinite, because as you can see, the plane is not closed. It goes infinite. It is large for infinite size. And the third possibility is negative curvature, which is like the curvature of the surface of a saddle, like in the middle here, when the curvature is negative. Yes, the negative curvature is like the saddle. Yes. Then the universe is not closed or at all, and it is infinite. So if it is positive curvature, then the universe is like a sphere, and it is closed. It is closed. But if the curvature is negative, then the universe is infinite. And also, if a curvature is like a zero curvature, and it is like a plane flat, then the universe is also infinite. If the isotropic and homogeneous if the universe is isotropic and homogeneous, and the curvature of the universe has a constant positive value, yes, like this, like the sphere, then the universe will be finite, just as a surface of a sphere. Yes, when the curvature it is positive curvature, and the universe is finite. On the other hand, if the curvature of the universe is a constant of zero, yes, like here, there is actually zero curvature. There is no curvature at all. Then it will be like a plane plate, and the universe will be infinite. Or it is a negative, constant negative curvature. That is to say, the universe opens outwards and never closes. Yes, as you can see, it opens outwards and it never closes. So in that case, the universe also be infinite. The universe is infinite. So, do we have any measurement of the amount of curvature that the universe has? Yes. Yes, there is. The standard model of cosmology, which successfully fits all measured cosmological information, as a parameter total omega, which is related to the curvature. If total omega greater than 1, like here, total omega greater than 1, yes, the universe is positively closed, like the sphere. If total omega greater than 1, then the universe is closed like the sphere. if total omega equals exactly to 1, then the universe is flat. If total omega equals to 1, then the universe is infinite, like a plane plate. And if the value of total omega is less than 1, the universe is negatively curved. If total omega is less than 1, then the universe is negatively curved, and it is like a saddle and infinite. The best measured value of total omega is actually, as you can see, total omega equals to 1 minus 0.12. Okay, that is to say total omega, and if total omega equals to 1 plus 0.12, that is equals to 1.12, that is to say total omega is greater than 1, then the curvature of the universe is positive. Like here, the curvature is greater, total omega greater than 1 is, so the universe is closed. And so the universe is positively, the curvature of the universe is positive, and the universe is in a shape of a sphere, like you can see here, and the universe is closed. If total omega equals to 1 minus 0.12, that equals to 0.88, that is less than 1, so total omega equals to less than 1, then the curvature of the universe is negative, then the universe is in a shape of saddle, like in the middle. You can see the shape of the universe is like in a saddle, and the universe is infinite. Okay? Which obviously, so we have all the possibilities. So it is obviously could encompass everything from positive to 0 to negative curvature. So there is no definitive answer to this point, but the universe is consistent with having 0 curvature, because the total omega is close to 1. Yes, because it is 1 minus or plus 0.12. It's close to 1. And when, if theoretically total omega equals to 1, then it is 0 curvature. It is 0 curvature, and it is like a plane plate, and it is infinite. So we really don't know if the universe is infinite at this point, but since the value is so close to flat, that is close because it is close to 1, yes? It is either 1.12 or 0.88, it is close to 1. So even if the universe is positively curved and finite like this, a sphere, it would definitely be much, much bigger than the observable universe. Okay, so we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. At the moment, we don't even know if it is finite or infinite, but there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.